Okay, part 2. Once we decide where the function is increasing or decreasing, that then can lead us into indicating relative extrema, relative mins and relative maxes. We've already determined in the last lesson about absolute mins and maxes, or mins and maxes on a closed interval where we consider endpoints. Relative extrema, we only consider interior values. We also, in order to be a relative min or a relative max, your function has to actually be defined at that point. So we can't have an asymptote at that point. We could have an asymptote where we're increasing on one side and decreasing on the other side, but that doesn't make the asymptote a min or a max. So I jumped ahead a little bit. How are we going to determine relative mins and relative maxes, or relative extrema? Okay. It's going to go directly from our increasing and decreasing relative min, max. If a function is increasing and then decreasing, and it's defined in between, we're going to have a relative maximum at that value. The way we're going to find that is it's going to be that indicator, that spot where the change goes from increasing to decreasing, that creates the maximum. Vice versa, if our function is decreasing and then increasing, if we're going downhill and then we're going uphill, and we can prove that through slopes, through derivative values, and we have a defined point in between, okay, the original function is defined, f defined, then that changeover point makes a relative minimum. So, just like, and I guess that's kind of what I forgot when I was doing the last video, you've already done critical value finding. Lesson 24, finding critical values, taking your derivative and setting it equal to 0, was already a part of the process. So when we did that to find the increasing, decreasing, that was no big deal, or was not the first time you had talked about it. Finding relative extrema, we're going to start the same way. We're going to start with f prime of x, and we're going to think about it equal to 0 or undefined. So f prime of x in this case would be x squared minus 6x minus 27. A little bit of an easier factoring one than the last one. Honestly, they're not trying to like mess with your head in Calc AB and trying to give you like impossible things to factor. You know, typically if you're being expected to do factoring to generate critical values, it's going to be something that factors pretty nicely. Okay. Minimum effort. So, critical values, places where my derivative of f equals 0 or f prime equals 0 are at 9 and negative 3. I then roll my number line analysis for f prime, x minus 9 and x plus 3. And maybe, 0 is easy to work with. Creates a negative. Positive on that side, positive on that side. I mean, parabolas will have nice predictable behavior. It's always a little bit more interesting when the function's a little weirder. So here's what this number line tells me. It tells me f of x has a relative max at x equals negative 3. And how do I know that? f prime changes from positive to negative. We know what f is going to do because of f prime's behavior. Similarly, f of x has a relative min at, not x, at x equals 3. How do I know that? F prime changes negative to positive. You have to be specific about the change because the different type of change creates the different behavior. So you've got to make sure you're describing a change in f prime that leads to a relative maximum or a change in f prime that leads to a relative minimum. Now, since this video is a little shorter than the first one, I'm going to back up. And let's do problem 2. This was just a question about increasing. And my function is 2 sine x cosine x. To do f prime, I'm going to have to follow the product rule. So cosine x times the derivative of 2 sine, which is 2 cosine, plus, so this is g, if this is g and this is f, there's my g and there's f prime, and then there's f and g prime. Derivative of cosine, negative sine. G f prime, f g prime. So my derivative is 2 cosine squared x minus 2 sine squared x. Where is f prime equal to 0 or undefined? That's going to be my question. Cosine functions and sine functions are defined everywhere, so we're not going to have any undefined issues. We don't have any denominators to be 0. We don't have any asymptotes, anything like that. So 2 cosine squared x minus 2 sine squared x equals 0. Remember, this is on the interval 0 to pi. So we're not looking at them overall. I'm going to do a factoring here. I'm going to factor out a 2. Lots of algebra techniques we can use here. This would be the one I would do. And then think about my difference of 2 squares. So cosine minus sine and cosine plus sine. So cosine minus sine equals 0 would mean the cosine and the sine are the same. And if I'm only looking at quadrants 1 and 2, that's going to happen at pi over 4. For this guy, the cosine and the sine together, added together, make 0. So that means they are opposites of each other, which happens at 3 pi over 4. So I'm only going from 0 to pi, but one of my critical numbers is pi over 4, and one of my critical numbers is 3 pi over 4. Now notice that just because this was trig, I didn't do a different basic approach. I'm still doing the same idea. I'm finding my derivative. I'm setting it equal to 0. I'm finding the critical values. I'm building a number line. Within this number line, I'm going to analyze the sign of my derivative. Okay. To determine where f prime is positive or negative, so that I can decide where f is either increasing or decreasing. So yeah, this is a little, like, extra fun. Pi over 2 is a good middle number. Okay, so if this is pi over 4 and this is 3 over pi over 4, pi over 2 is a good middle number. And so pi over 2 in here will be 0 plus 1 and 0 minus 1. So that'll be a -2. If I plugged in pi over 2. If you're like, well, what the heck am I going to plug in between 0 and pi over 4? How about pi over 6? Now, I gotta admit, I'm usually bad. I still think like degrees sometimes. So cosine of pi over 6, 30 degrees. Cosine, so root 3 over 2 plus a half. And so root 3 over 2 minus a half. That's positive. That's positive. That's still positive. This is all going to be positive. Oops, wrong side. I don't really care what number it is. I just care positive or negative. All right. So this was pi over 6. Now I need something bigger. How about 5 pi over 6, right? So that'll be negative root 3 over 2 plus a half. And negative root 3 over 2 minus a half. This is negative. This is positive. That's bigger than 1. Root 3 is bigger than 1, and it's negative. So something bigger than 1 that's negative plus 1 will stay negative. No way. So, ugh. Yeah, this is super triggerlicious. All of that work, our derivative, which took work, our critical numbers, which took work, our evaluating of f prime around those critical numbers took work to look at the signs. And what did we end up determining? I don't know if I can zoom it out enough so I can see everything at one time, but here's my number line. And I was looking for increasing. So let's take this one step further and let's say I know that f is increasing on the interval 0 to pi over 4 and 3 pi over 4 to pi. How do I know that? F prime greater than 0. So it must mean, this is where we would ask this out loud, even though this wasn't the question, we must have a maximum here, and we must have a minimum right there. Now, nothing like a picture. So remember, the original function was 2 sine x cosine x. I'm going to graph it. And, you know, I don't need to see all of that. I just need to see the 0 to pi part. So here comes the 0 to pi part. And I'm just going to make my y's just a little less y, so it's spread out a little bit. Okay, so what do we see? We see a function that's increasing and then decreasing and then increasing. And if we ask the calculator where that changes, where is that maximum, calculator? What is that peak? Oops, did I not get it where I wanted it to be? Oh, what am I doing? I'm gonna calculate, oops, I wanna calculate. Oh, did I do the minimum? I think I did. I was like, that didn't give me the right answer. You know why? Because I asked for the smallest number in the interval, not the largest. Okay, so there's the interval. There's the peak. The peak is at 0.785. Guess what? Yeah, right? So looking at F's graph, and let's take it back to from 0 to pi. Looking at F's graph from 0 to pi, we are seeing exactly the behavior that we described here. It's increasing from 0 to pi. Oops, where do we go, bunny? It's increasing from 0 to pi, and then it's decreasing, and then it's increasing again. Because remember, this is the slope. The slope of this function is positive, and then negative, and then positive.